So we are looking at our second day. Today we're going to look at graphing absolute value inequalities, which are a little bit different than graphing inequalities themselves. So we have a couple of rules that go with graphing these absolute value inequalities. So you're going to hear me emphasizing in the words great or. You'll hear me emphasize or, and less than is and. So you're going to hear me emphasize the and aspect. So when we talked about inequalities on Friday at the beginning of the unit, we just talked about and or inequalities, and they were given to you. You could tell if it was an and or right off the bat. Now, when we talk about inequalities, we're going to have absolute values with them. So we have to actually look at two parts. And in order to do that, we need to determine if it's going to be a union or an intersection. So here you can see that the absolute value is great or. So it's going to split to an or. If it's less than, it splits to an and. So in that first example, we have the absolute value of 2x minus 5 is great or than 3. So we're going to split this absolute value just like we split absolute values before. So you're going to have the positive side. But then we're going to also split it to a negative side. But we know that if an inequality is divided or multiplied by a negative, the direction of the inequality changes. So with absolute value inequalities, we also change the direction for the new negative side. So you have 2x minus 5 is greater than 3. Or 2x minus 5 is less than negative 3. Solve for x. So you get x is greater than 4 or x is less than 1. On your number line, you want to make sure you have values to the left and right of both of these. So maybe I start with negative 1. Both are greater than, but not equal to. So both get open circles. Less than 1 shades left, greater than 4 shades right. Number 9, absolute value of 2x minus 3 is greater than 7. So drop the absolute values, rewrite the problem as is. This is an or. Rewrite the absolute value with a flipped inequality and a negative value. Solve for x. Now, even though there's a negative 4 here, you divide it by a positive 2, so the absolute value direction does not change. So you get x is less than negative 2 or x is greater than 5. Once again, both are open circles. I need to see that clearly, and shaded in opposite directions. Okay, next two examples, we have absolute values, but my absolute values are not isolated. So just like the other day, if you were trying to solve an absolute value, whether it has an equal sign or an inequality, you still need to isolate the absolute value first. So before I can split this problem, I have to get the absolute value alone. So I'm going to subtract the 5 and divide by the -2. When I divide by a negative, the absolute value doesn't change, but the direction of the inequality does. So you get the absolute value of x plus 1 less than 4. Now my absolute value is isolated. Once the absolute value is isolated, you split and solve. So subtracting 1, I get x less than or equal to 3 and x greater than or equal to -5. So again, this is an and, so they should overlap or intersect. So we have -5 and 3. These are closed circles, and we shade between. Okay. In 11, you're going to add that 7 to both sides to start. So you have 5z plus 3 less than 41. So again, it's a less than or and. So you get 5z plus 3 less than 41 and 5z plus 3 greater than -41. Subtract 3 from both sides and you get 38 and -44. Dividing by 5. We see that z lives between -44 divided by 5 and 38/5. So 38/5 is 7.6 and -44/5 is -8.8. So obviously we're not going to be able to graph these exactly. So what you want to do on your number line is try to get it so they're as close as possible. And for this number line, we can't go by twos because we won't, well, I guess we can, but you won't quite make it on the negatives. Open circles, shade between. So actually, what you'll notice though is I took my answer and up here, I left my answer as 2 inequalities. Down here, I had rewritten it as 1. And problems answers can be written either way. Any and inequality can be rewritten as 1 answer or 2. So this could actually have been rewritten as x greater than or equal to -5 and less than or equal to +3. So and inequalities, not ors, only ands, can be written as a single solution. Okay, find the absolute value inequality statement that corresponds to the given solution. So in order to rewrite an absolute value inequality, we need to do 2 things. We need to know what is the distance between those 2 points. So we know that distance is represented by the absolute value, that number is from 0. So in this case, the distance, 2 is to 0, or -2 is to 0 is 2, 4 to 0 is 4, so the distance between the endpoints is 6. Then what we're going to do is divide that distance in half, making it 3. Then we want to look for the new endpoints to be plus or minus the value calculated in step 2. So what that means is you're going to either pick to add or subtract 3. So let's say we add. So we get 1 is less than x plus 3 less than 7. So up here, when your answer is written as a single inequality, we know that that means this is an and problems are less than. So when you're looking for the absolute value of an and problem, you want the absolute value to be less than the number. So what we're going to do is we're going to take the left side and kind of ignore it. And we're going to use the right side of the absolute value, or the inequality, to write my absolute value. So we're going to say that the absolute value of x plus 3 is less than 7. And the idea is that if you took this absolute value, you could rewrite it and split it and get back to that answer set we started with. And you've now created an absolute value for a solution. Okay, so let's do the same thing, but with an or. It says find the absolute value inequality statement that corresponds to the inequalities. So the first thing you need to do is find the distance between the 2 points. So you need to know how far apart is 19 and 24. So their distance is 5. Then you need to find half the distance. So in this case, that's 2.5. Then we're going to adjust our answer by adding or subtracting 2.5. So let's say we subtract. So you have x minus 2.5 less than 19 minus 2.5. X minus 2.5 is less than or greater than rather 24 minus 2.5. So now we have x minus 2.5 is less than 16.5 or x minus 2.5 is greater than 21.5. Since this is an or, it is greater. So you're going to pick this side and say that the absolute value of x minus 2.5 is greater than 21.5. Okay. Then the remainder of your time is for your homework.